Section 2.2 and 2.3 are about rates of change and a little bit of graphing lines. First, I want to talk about rate of change, and rate of change is slope. I'm going to be referring to it more as rate of change rather than slope because the problems we're going to work with, we're talking about rates of change, so that's what I'm going to call them. So here we have the rate of change, or the slope, as words, algebra, and graphically. We're going to represent it. First off, in words, the rate of change is the vertical change, or the rise, over the horizontal change, or the run. And you can see that over here on the graph. I'm going to jump over to the graph. You take the vertical change, the rise, and if we want to find out how much this graph is rising, we're going to take the y2 minus y1 to get how far vertically changed, which is exactly what's over here, and this is the vertical change, and then that's divided by the horizontal change. So if I want to find out how far we moved horizontally, I take x2 and subtract x1 to find out how far it moved here, which is x2 minus x1, and this is the horizontal change. So how far it moved up and down over how far it moved side to side. That's how you find rate of change. So if we're just doing a simple problem where we want to find the slope, we're talking about skateboarding, and a skateboard ramp has a rise of 15 inches and a run of 54 inches. What is the slope? Remember that rate of change is rise over run. In this problem they give you the rise and the run. They say the rise is 15, that's the vertical change. That's how far it went up, over the run, which is 54. Rate of change is always in simplest terms, so we're going to reduce this. We can take a 3 out of both of these and we'll get 5 over 18, and this is inches. So what if we were looking at a graph? If we were looking at this graph, and I said, what is the slope of the line that passes through the points -1, 3, which is right here, this black dot, and to -1, which is that dot. I'm going to take the vertical change over the horizontal change, or rise over run. And my formula up above was y2 minus y1 over x2 minus x1. Really, it doesn't matter which you make 2 and which you make 1 as long as you go in the same direction. So I could start over here if I wanted. Even though it says y2 minus y1, I could start over here. I could do 3 minus a -1. As long as I go the same direction on the x's, I can do -1 minus 2. And that means my slope is -4/3. Alright, so those are simple review problems. We're going to quickly talk about the classifications of the lines by slope. If you have a positive slope, your line is going to rise from left to right. That means that if you move from left to right on this graph, if you pretended you were walking upstairs from left to right, if you're walking up the stairs, that means you have a positive slope. It's rising from left to right. If you have a negative slope, that means that your graph is rising the opposite way, from left to right. So if you pretended that you were walking this way, from left to right, if now I'm walking down the stairs, that means I have a negative slope. If you just have a horizontal line, that means you have a slope of 0. And if you have just a vertical line, that means you have an undefined slope. And this is why, and this is really important to understand. If I was finding the slope of a line, remember it's rise over run. If I'm looking at this horizontal line, there's no change in the run. It's not going up and down at all. It's only going side to side. So there is no rise. The rise is 0. over whatever number. It doesn't matter what it is. This could be anything. We'll just put 6 because 0 over any number is just going to be 0. So that's why the slope is 0. Over here it's undefined because it's the same thing. Slope is still rise over run, but if it's a vertical line, it's constantly changing, rising, but there is no run. It's not moving side to side at all. So it's some number, whatever, we'll pick 6 again, over 0. And you can never ever divide by 0. It's just not possible. The world will end if you divide by 0. So that means it's an undefined slope. So if we're not graphing at all, without graphing, we're supposed to tell between the line that goes between these 2 points if it rises, falls, is horizontal or vertical. We can tell that just by looking at the slope. So if I find the slope, and if you're having trouble with this, you can always label your points x1, x2, y1, y2, and then fill in your formula. So we have -1 minus 6, y2 minus y1, and x2 minus x1, 4 minus 4. And we can already see on the bottom it's going to be 0. And you can never divide by 0. So this has an undefined slope, which means that the line is vertical. Now a couple notes about parallel and perpendicular lines. You should already know that parallel lines have the same slope. If they're parallel, they never cross, no matter what they look like. They're parallel, they have the same slope. If they're perpendicular, the slopes are negative reciprocals. Perpendicular would make a T, and that means their slopes are negative reciprocals. So if this line had a slope of 6, that would mean that this line would have a slope of a negative reciprocal would be -1/6. The equation of a line, this is back to Algebra 1, in slope-intercept form is y equals mx plus b. And I'm just going to quickly review the 2 ways that you can graph lines. If it's already in slope-intercept form, it's pretty simple. This is your y-intercept, and the number in front of x is your slope. I graph my y-intercept first. This is -3, so I go down to 3 and put a dot. And then use my slope of +2, so I go up 2 over 1, up 2 over 1. And that's my line. If it's not in slope-intercept form, I can get it there. I can solve for y if I like, and then graph it the same way I did here. Or you can plug in 0 for x and y and get your intercepts. If I plug in 0 for x here, I'll write it out, but you wouldn't have to write all this out. And that becomes 0, and then to solve for y, I just divide by 2, because that's 0. So y equals 5. That means I have a dot at 5. And then I do the same thing, I put in 0 for y, and find out what my x-intercept is. So that goes away, and I divide by 5, and x equals 2. And then I can just draw a line between those 2 points. If you don't like that way and you want to solve for y, you can take this solve for y, that's fine, you can do that too. So this is the most important part of the lesson because we're getting into context questions and we need to know what the variables stand for and other things of that nature. And if you're able to do this, this will be really beneficial for you in the future in many other things that come up, not only in my class, but other classes, especially science classes. So here we're talking about the body length of a walrus, and it says the body length is y. So the body length is y in this problem. Of a walrus calf can be modeled by this equation. That means that we can, when it says it can be modeled by this equation, we can find the length of this walrus calf by using this equation, where x is the calf's age in months. So y is the length and the calf's age is the x. First part, we want to graph the equation. Something like this, you can use the y-intercept 42 and use the slope of 5, but sometimes you don't have nice numbers like this, you have like crazy decimals. So what I'm going to tell you to do is to plug in numbers when you're using context questions, but you got to be smart about it. X stands for the age of the calf in months. You're probably not going to have a negative age of a calf. That doesn't make any sense. It's not born and then all of a sudden is -1 month old. So when we start, we're going to plug in 0 because that makes sense. 0 would be when the calf is born. That's the length of the calf. So from there, I'm just going to go up by 5 months. So I'm going to plug in these x's into this equation to find out the length of the calf. So if I plug in 0 in for x here, I have 5 times 0, 0 plus 42 is 42. So when the calf is born, it's 42 inches long. If I plug in 5 here, I have 5 times 5, 25 plus 42 gives me 67. If I plug in 10, I'm going to get 92. If I plug in 15, I'm going to get 117. And if I plug in 20, I'm going to get 142. So now to make the graph, we only care about this first quadrant because we don't have any negative numbers. And our x's were the calf's age in months, and y was the length of the calf in inches. Five, 10, 15, 20. And for my y's, I'm going to start at 40 and go by 15s. So I have a little break in my graph right here. Okay, so now I'm going to graph my points. I have 0, 42, 5, 67, 10, 92, 15, 117, and 21, 42. So you should get something that looks like this. Now the questions that follow. Describe what the slope and the y-intercept represent. The easiest one to look at first would be y-intercept. The y-intercept is where it crosses the y-axis. We know that it crosses at 42 because we have a point that's 0, 42. That would be, if we're at 0, y equals 0, that's the age 0. So when the calf is born, if we're at 0, this is the point 0, 42. The calf is 42 inches long. So what does the y-intercept represent? It represents the length of the calf when it's born. So then what does the slope represent? First off, let's find the slope. And to find the slope, you can take any 2 points, it doesn't matter. So I'm going to take the first point we have, 0, 42, and the second point, just because they're the smallest numbers. It does not matter what 2 points you choose. So if I do y2 minus y1 over x2 minus x1, I'm going to get 5 over 1. So that would mean y is inches, x, remember this is change in y over change in x. That means that every month the calf grows 5 inches. Then the last question, use the graph to estimate the body length of the calf at 10 months. Just look at our graph, and it looks like he's about 92 because we plugged in that point. So you would say about 92 inches in length. These are two simple problems on finding slope, and I want you to do these ones in your notes for next class.